A ground fault circuit interrupter, or GFCI, is a safety device designed to protect people from electrical shock. It works by monitoring the current flowing in a circuit. If it detects the difference between the outgoing and returning current, which indicates a leakage of current, known as a ground fault, it quickly trips the circuit, cutting off the power. The reported voltages of 58 volts hot to neutral and 73 volts hot to ground, along with the GFCI not tripping, indicate a problem that requires careful investigation. Several potential causes could explain these symptoms. Firstly, improper wiring. It's crucial to ensure that the hot, neutral, and ground wires are correctly connected and securely fastened to the GFCI receptacle. Look for any reversed connections, where the hot and neutral wires might be swapped, or any loose connections that could cause voltage drops and prevent the GFCI from functioning correctly. Secondly, a bad GFCI. The GFCI receptacle itself could be defective. Even if it appears to be wired correctly, internal damage or component failure can prevent it from tripping when a ground fault occurs. The best way to rule this out is to remove and replace the GFCI with a new, known good one. Thirdly, grounding issues. Proper grounding is essential for a GFCI to function correctly. Verify that the ground wire is properly connected to the electrical panel and to the grounding rod or other grounding system for the house. Inspect the grounding rod itself for corrosion or damage, as this can impede its ability to provide a safe path for fault currents. Fourthly, an overloaded circuit. If there are too many devices plugged into the GFCI receptacle, or others in the same circuit, it may cause an excessive voltage drop. This voltage drop can prevent the GFCI from tripping even when a ground fault exists. Try unplugging unnecessary devices from the circuit and then test the GFCI again to see if it trips. Fifthly, a voltage imbalance. Check the voltage at other outlets in the home to determine if the issue is isolated to the GFCI receptacle or it's a more widespread problem. If other outlets also exhibit low or imbalanced voltage, the problem might be with the electrical service entering the home. This would require the attention of a qualified electrician and potentially involve the utility company. Here are some additional checks to perform. Firstly, connection integrity. Use a continuity tester to check that the neutral and ground wires are connected to the correct terminals on the GFCI receptacle. This test will confirm that there are no breaks or high resistance connections in the wiring. Secondly, use an outlet tester. Plug an outlet tester into the GFCI receptacle and other outlets in the circuit to verify proper wiring and grounding. These testers can quickly identify common wiring errors such as reverse polarity, open ground, or open neutral. Thirdly, polarity testing. Ensure that the hot and neutral wires are connected properly. Reverse polarity can affect the GFCI's functionality and pose a safety hazard. A polarity tester can confirm correct wiring. Fourthly, electrical panel inspection. If possible, and if you are comfortable and qualified to do so, inspect the electrical panel for any loose connections, corrosion, or other issues that could contribute to the voltage drop or grounding problems. Look for any signs of overheating, such as discolored wires or melted insulation. Remember these safety precautions. Firstly, always turn off the power at the electrical panel before working on any electrical circuits. This will prevent accidental electrical shock. Secondly, use a non-contact voltage tester to confirm that the power is off before starting any work. These testers can detect the presence of voltage without requiring direct contact with the wires. When dealing with electrical issues, safety is paramount. If you are not comfortable or qualified to perform these tests and inspections, it is best to consult a qualified electrician.